Hello, the question for today is introduction of a dielectric substance between the plates of a capacitor increases the capacitance Y. So we have a capacitance, we have a capacitor actually. So let the plates of the capacitor be like this. This is one of the plates. This is the another plate. This is connected to the negative terminal of the source. That's why it has got a negative charge like this. So let me use 6 of them. And this is connected to the positive charge. So it is a plus, 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 plus. So when the plates of the capacitors are fully charged, this will have an electric field. So electric field will be directed from plus to minus. So the direction of the electric field will be like this. So this is the original electric field, which we write as E. This is the original electric field. And the potential difference is also, this will also be V. The separation between them is D. So that's why initially or originally for this capacitor, I will have E is equal to V by D. So this is equation number 1. And the value of V is determined by the charges that are deposited in the plates here and here. Now if I use a dielectric substance, so let me introduce a dielectric substance here. So this is the substance. Actually I fill the whole space, but since we cannot show it here, I have made a small gap here. So this is the dielectric substance which fills the whole space between the plates of the capacitor. So its thickness is also D. Its thickness is also D. So let me write it D here. And when we do so, its molecules get polarized, and that's why the molecules will become somewhat like this. They become polarized like this. This is minus plus. This is minus plus. So it goes on and on till minus plus and minus plus. So that means this end of the dielectric substance will be negatively charged and this end will be positively charged. So let me write it as, so minus, 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 and plus, 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 plus. So that means inside the dielectric substance, there will also be another type of electric field. So this electric field will be from this plus to minus. So the electric field here will be from here to here. And this E will be written as ED. It will be written as ED. So this is the electric field inside the dielectric. So what we have now is this ED is equal to electric field inside the dielectric substance. So this means now the resultant electric field. So the electric field resultant will be, so the electric field resultant in the space will be equal to E minus ED, because these two fields are in opposite direction. So we have E resultant is equal to E minus ED, which means this E resultant is less than this E. So E is the initial electric field here, E resultant is the final. So this will be less than this. Now the capacitance of the capacitor will be equal to, so the original capacitance, so initial capacitance will be equal to, which I write it as C, that's equal to Q by V. V is the original PD. So from this equation I can write here V equal to E into D. So that's why this is Q by E into D. This is the original capacitance. Now the capacitance of final one is, so final capacitance will be equal to, so let me say C final, that's equal to Q by V final. So this will come out to be, it's equal to Q by E resultant which is the final value of E as well, into D. So now if I compare these two equations, this is equation number 2 and equation number 3. So if I compare these two equations, so let us see here, since we have got this thing is smaller than this, E resultant is smaller than this, so that means this CF should be larger than this. If this thing is large and this thing is small, this thing should be large and this thing should be small. So that means so I can write here, since E resultant is less than E, comma, so equation 2 and 3 give C final is more than C. So the final capacitance should be more than the initial capacitance. And this is one of the finest way of increasing the value of capacitance in industrial and normal use.